Hello, hi guys. So we're going to start with our first chapter, which is working with big data. Before we start, I'm going to ask you about what is big data. You all hear about this big data every day. You read it on the internet, but most of you just maybe have a sort of idea what is big data, but you don't know what is the clear picture about big data. Okay, let me tell you the analogies about big data. Okay, let's see here. There are three social media here, three apps, and also a concept of smart home. Okay, you use these three social media every day, maybe one of it, like Twitter, Instagram, TikTok. For example, um, you use a Twitter to tweet your opinion, to tweet everything that happens in your life, and also you have followers on your Twitters. Then your followers will respond to your tweet by like it, retweet it, or just commenting or quote on your tweet. Then from your tweet, also the other followers will RT it and also respond to your tweet. Then the tweets become something else, become viral, whatever it is. Then it produces data. Same goes on Instagram. You post a video, a picture, and story. All that will produce data. The same concept with the smart home. Smart home has all the sensors, like how to control the light, the aircon, and everything. And everything that you have inside your house can be controlled by the apps. So all these senses for this, not just a very few data, is produce a big data because the data that's sent from the sensor is produced like every seconds, every minutes that the user set up for this home. So that is a big data, basically the something that you produce from social media or from sensor that you need to read the data and it's very large. Okay, if you still didn't get the picture on what I'm talking about in the previous slide, so here is the facts that we get from 2019. That was like 2 years ago. Okay, this is what happened in an internet in 1 minute, in 60 seconds, 1 minute. Okay, for Facebook, see there is 1 million people logged in and 304,000 47,222 scoring the Instagram, and then 1 million views on Twitch, 4.8 million surf in Jiffy. So there is a lot of people surfing different types of apps in 1 minute. This is what we're talking about big data. Okay, for like example for Google, there are 3.8 million search queries for every minute. So you can imagine how big it is. So that is why big data is very important since the evolution of the internet. Okay, now that you have a picture already, what is big data all about? Okay, let us just define what is exactly big data by definition. Okay, by definition, big data is a volumes of data available in varying degrees of complexity, generated at different velocities and varying degrees of ambiguity that cannot be processed using traditional technologies, processing methods, algorithm, or any combination of the shelf resolution. Okay, there are some important keywords in this definition, which is three V's, but now as the evolving of the internet and on all the technologies, we have like four V's now. Okay, which as I'm going to explain on the slide after this. Okay, for the meantime, we just focus on the three V's, which is volumes, velocities, and variety. Um, Big data has to big in volume, okay, and the velocities is very um, the speed of the data. That means how they can define whether the data is big or not, and the variety of the data. Uh, the data must vary, has varieties of data, not just one type data only. Okay, then the data can fit on a local computer in the scale of 0 until 32 gigabyte, depending on RAM. But what can we do if we have a larger set of data? Maybe we try to using a SQL database. I think you already learned this SQL in the previous semester. Okay, or use the distributed system that distributes the data to multiple machine or computer. This is what exactly we're going to use or going to handle with big data. And I think in this course we're going to use the Hadoop. Okay, the technology as a technology to handle this big data lah. Right, this is what I'm talking about, the 4 V's. Volume, velocity, variety, and veracity. The veracity is the new addition of the V's based on the evolution of the technologies. And okay, but the book that we use in this course are still in the backwards. It's not the latest one, so we just focus on the three V's just now, which is volume, variety, and velocity. Okay, volume is in terms of how large, megabytes or terabytes or gigabytes per hour. So that is volume. Variety, um, how many different type of data, just one or data or lots of data. Okay, velocity, as I already explained in previous slide, velocity is how speed, the speed of data transferred for every hour, every second, and every minute. So that is velocity. So we just focus on these three V's for now. Okay, let's say data volume. Okay, data volume is amount of data. So example of data generated by different sources. Okay, there are 5 here. Machine data, application log, stream logs, external or third-party data, and emails. I think most of you has emails lah, but I'm going to explain each of these example that data generated for different volume. Okay, for the first one is machine data. Okay, here is stated that every machine or device, can be a device, your sensor, okay, can generate a lot of data, includes both usage and behaviors of the owners of this machine, also includes detailed activity logs. The figure you can see after this slide. Okay, machine generated data is characterized by a steady pattern of numbers and type which occurs in a rapid fire fashion. So there are 3 examples here of machine generated data. First one is a robotic arm. There is an assembly line at an automotive plant. So here is a manufacturing. Okay, the robot will send a signal for every movement it makes, and the pattern will be steady as opposed to a dredging machine that is doing road work and sending signal back on how much movement it had during the day. Second one is sensors on top of building. Okay, and third one is sensors on automobiles send different signals. Okay, this usually car, the one Tesla, okay, that self-driving car, okay, that has a lot of sensor. Okay, so that's maybe Tesla car, because it has no driver, so it has to send signals depending on that road type, driving speed, weight, and motor support center. All these data, okay, from the car, okay, will be sent to the support centers, and the data is consistently, I mean, it's, it's not the same, it's just from the machine. Okay, that's what is the meaning of the data generated by machine data. Okay, The bottom line is the data is right once in most cases. Okay, but I think the automobiles is not no road once, maybe keep adapting based on the different type of road and driving speed. Unless the driving speed is very consistent, I don't know. I don't have Tesla. Okay, I'm not that rich. Okay, right. Will not have not have an update for the same content. Except in case, okay, except in the case of corporate documents. I think it's not just except for the corporate document size. Valid. It's very. I mean, it differ on the application itself. But you get the idea. What is the data from machine data? What I'm trying to say here. Okay, let's move on. Again, before that, this is the figure. Machine data from an interactive gaming system. Okay, I think it can be also take an example from PS4. Okay, it also can be considered as a machine data. Every time you play a game, you save it. Okay, so this is the type of data. Okay, second one is the application log. Okay, this is another form of machine generated data, but it's different in terms of devices lah. Okay, machine data previously is only on one machine or one device only, but this one is different devices. Okay, different devices generate logs at different places and format, so it's not cannot be a same formats of same pieces. Okay, for example, we have CT scanners, X-ray machine of all the equipment at the hospital. Okay, body scanners at airport. If you ever travel, okay, you know when they scan off from at the board at the airports and the data will be sent. Airplane, ships, military equipment, commercial satellites, and others. Okay, for today, if you have a smartwatch, so that also can be considered as application log lah. When you wear your smartwatch and you run, you take a step, or the calculated step in your smartwatch is considered as application log. I think that is the most easy and example to understand. Okay, and also your cell phone that you use every day. Okay, every time you log in to your phone to check an apps, that is considered as application log. Right, the third one is clickstream log. Okay, figure both shows a typical clickstream log. Clickstream log is usually on the click. Okay, the user stay on the web page are captured in the clickstream data. Okay, when you click on the the example of Shopee. Okay, every time you browse and you see something might be interested you and you click on that product, okay, that is considered as clickstream data. Also another one, I think what else? Clickstream, when you browse anything that you like, okay, and then the web page, okay, something like that lah. Not sure. Okay, retail shopper usually involving on clickstream data. Other than that, cannot think of. That's the simple example. Okay, but the biggest problem with the data on the clickstream is the volume. Okay, because every time you click, it produces the data. So it cannot be just one click. You have to click. I mean, every time you shop, you click this and then you click another product and then you click another product. So that's produce a lot of data lah. The data is very huge in volume. Okay, current tools can only gain partial information from this data. Today, since data format vary across the system and the sheer volume makes it hard for current technologies to process the data. Okay, this is a problem case lah for this clickstream logs. Okay, next one, external or third party data. Okay, This is an example of data that you don't have. Okay, there is other people that have it, but you need to access the data. Okay, for example, where the data. Okay, you don't have the data. The data is from the material like Malaysia meteor. Ah, it's really hard to meteorological department. Okay, so they produce the weather data. Okay, and you want to access, okay, that's what is meant by external or third party data. Okay, the last one is emails. Okay, this is in this example, they are talking about the working emails. Okay, not the individual emails. So, for your example, you can relate to your student email probably. Okay, every enterprise. Okay, there's a formal email. Has massive amounts of email that generated by its employees, customer, and executive every day. Okay, like me myself, I receive at least 10 email every day. Okay, that's just me. Okay, but in the UMP itself, maybe there we have a UMP has a lot of employee, and then not just if one person, one employee like me receive 10 email, then how about the others 100,000 employee? Okay, so the emails that we generated every day is very large amount lah. Okay, these emails are all considered an asset of the corporation and need to be managed. If enterprises do not understand the associated risks, liabilities, and penalties associated with email management, it is time to set policies in place. With the new information processing platform, emails can be processed using text mining rules and algorithm and flag for risk exposure and non-compliance. Proactive management of this content is needed for every enterprise. There are several complexities associated with processing this content, including metadata, ambiguity of language, expression, and contextualization. Okay, basically, they are explaining how to manage the email for the enterprises and how the employees should treat the email, especially the important one. Okay, next one is data velocity. Okay, already told you twice. Okay, it's about the speed and direction of motion of an object, usually speed. Okay, we're going to focus on the speed here. Okay, from the old-fashioned, data is broken into feed-sized chunks and processed through different layers from sources to targets, and the end result is stored in data warehouse for further use in reporting and analysis. Okay, this is the old processing. Okay, in big data case, the data stream is in a continuous fashion and result sets are useful. When the acquisition and processing delays are short, the need becomes critical for an ingestion and processing engine that can work at extremely scalable speeds on extremely volatile sizes of data in a relatively minimal amount of time. So we're going to focus on this big data case where uh, we're going to um, speed up the process for the data that very large data. So we need the um, very suitable processing engine so that all the processing can be speed up. Okay. Um, Okay, for example, data velocity is this very important for the large companies such as Google, Apple, Facebook, and Amazon. Okay, the business adapted by all this for big companies. I think other than that also, um, which became the de facto business model for most big company, operate on the fact that by tracking customer clicks and navigation on the website, you can deliver personalized browsing and shopping experience. Okay, for example, Amazon. Amazon they sell a lot of things, so it is based on the click streams. Okay, I already explained to you this stream before this. Okay, there are millions of clicks gathered from users every second. Okay, amounting to large volume data, so it's related. Okay, this data can be processed, segmented, and modeled to study population behaviors based on time, day, geography, advertisement effectiveness, click behavior, and guided navigation process. The result sets of this model can be stored to create a better experience for the next of clicks exhibiting similar behavior. So they study the pattern. Okay, from the, let's say you are the person that we don't have an Amazon here, we only have Shopee, but just imagine you shopping on the Amazon. Okay, every time you clicks on the website, okay, they're going to study the data from your click stream. Okay, and then they model it. Okay, then they can see your behavior. What type of product that you like. I think the most easy way that you can see is from Facebook, Instagram lah. It's just like you think about the product, just think, not type anything yet. Let's say I think about chocolate today, and then suddenly the advertisement of chocolate appears on my timeline. You just think about it, not click, not yet. So that's how the all these big companies get the data. They already study your pattern and they already know your thinking, which is scary. Okay, then they create the better experience next set on for the next set of clicks as between similar behavior. That means they know you want a chocolate, so you're going to click that. Okay, that's what it means by study the pattern on behavior. Okay, the sheer volume of data is processed by these four companies has prompted them to open the technologies to the rest of the world. I think Google mostly that shares their technologies with the rest of the world. The other three companies, I'm not sure. Okay, but the velocity of data produced by user clicks on any website today is a prime example for big data velocity. So that is the bold keyword there. Okay, the velocity of data produced by user clicks on any website. So that is data velocity. Okay, another one is sensor data. Okay, I already explained to you about the Tesla. Okay, okay, data velocity come from a variety of sensors like GPS, tire pressure. Okay, Tesla things. Okay, all the data are generated from sensor. Okay, okay, another example, a flight from London to New York generates 650 terabytes of data from the airplane engine sensor. So that is one flight only. Okay, so you can imagine how big the data if there is 7 or more flights in a day. Okay, that's why the big data is very important. Okay, there is a lot of value in reading this information during the stream processing and post gathering for statistical modeling purposes. Okay, all this data is very important. Okay, mobile networks. I'm pretty sure every one of you has a phone. Okay. The most popular way to share pictures, music, and data today is via mobile devices. Oh shit. Okay, the sheer volume of data is transmitted by a mobile network, provide insight to the providers on the performance on their network, the amount of data processed at each tower, the time of day, the associated geographies, user demographic, location, and much more. Okay, the velocity of data movement is unpredictable and sometimes can cause a network to crash. This is always happen, especially in Malaysia. I think I think I face this like every day. I use Netflix and it sucks. Okay, always the network crash. I think there's one time the network crash on Celcom. Okay, thank God I'm not using Celcom. Maybe if you use Celcom, you can relate to that one. Okay, and then the data movement and its study have enabled mobile device providers to improve their quality of service. And associating this data with social media input sustainable insight into competitive intelligence. What it means by this fourth point is um, usually when the data crash, okay, there is an admin on Twitter or Facebook, they're going to uh, take a feedback from you, okay, and all this feedback they are going to use to supposedly to improve their service, but I don't think so. Okay, we move on to social media, which is I think everyone has at least one account, not Facebook, maybe Instagram, or maybe Twitter, or maybe TikTok, I don't know. Okay, I have at least two. Okay, I don't have TikTok, but I have Twitter and Instagram. So basically, different social media sites produce and provide data at different velocities and in multiple formats. Okay, so it's not the same for every social media site. Okay, not only the size is most important, understanding how many times it is retweeted or shared and how much follow on data it gets is essential to provide to process the entire data set. Okay, let's see. Twitter has a limit. Okay, so it is different velocities. Like Facebook, you can post like very long post. So the velocity is much bigger, and the format is also different. So that's by what it means by different social media policies provide different type of data and different format. Okay. A post can go trending or viral and have millions of posts as least an action volume to process. Okay, I think everyone can read it with at least one viral tweet, one viral post on FB. I don't open FB nowadays. Okay, maybe tweets. Okay, okay, that's a lot of data lah when the tweets become viral. Okay, the variety of data generation is the data velocity problem experienced by social media. Okay, when the data is too big, really when the tweet become viral, so the volatility of data generation is the data velocity problem. So this is what Twitter explains. Okay, again, not our problem. You just use your social media, I think. Okay, lastly, the data variety. Okay, variety is different formats. Okay, it range from emails to tweets to social media and sensor data. Okay, all this has a different format. Okay, already explained to you previously. There's no control over the input data, format or structure of the data. The processing complexity associated with the variety form of the formats is the ability or appropriate metadata for identifying what is contained in the actual data. So how the formats can define how much complex to process the data lah. Like example Facebook, so the format is different. The post can be longer, so the processing complexity can be complex more than Twitter. That's what it means. Okay, this is critical when process image, audio, video, and large chunks of text. And that's what I just said just now. Large chunks of text from the Facebook. Right, the absence of metadata or partial metadata means processing delay from the ingestion of data to producing the final matrix. Okay, the platform requirement for processing new formats are scalability, distributed processing capability, image processing capabilities, graph processing capabilities, video and audio processing capabilities. Basically, they required the platform itself, like Facebook, they required all these 5 requirements to process the data. Okay. Okay, there is 3 additional big data characteristic, which is ambiguity, viscosity, and virality. I think most of you to know more about the virality. Okay, data can go big when the posts or tweets can go viral. Okay. Okay, ambiguity is a lack of metadata creates ambiguity. For example, in a graph, M and F can depict gender or can depict Monday and Friday. Okay. For viscosity, the measures the resistance slow down the flow in the volume data. Resistance can manifest in data flows, business rules, and even be a limitation of technology. Variety measures and describe how quickly data is shared in people-to-people network. Rate of speed is measured in time. Okay, so this is all the definition for this additional keywords. Okay, advantages of big data. A local process will use the computation resources of a single machine. A distributed process has access to the computational resources across a number of machines connected through a network. After a certain point, it is easier to scale out to many lower CPU machines than to try to scale up to a single machine with a high CPU. Distributed machines also have the advantage of easily scaling. You can just add more machines. They also include fault tolerance. If one machine fails, the whole network can still go on. Okay, these are the advantages. There are lots more, but we don't just focus on these 5.